Okay, I'll be going through the magnetism worksheet on this iPad. So the first thing when you receive your worksheet is that you will see a star and a cross here, and you will see a star and a cross here. So I just want to get your attention to these 2 points because if you look at your textbook, this is the full text, you will see that it's indicated in your textbook that the magnetic north pole is on top. So let me grab this picture and put it on the whiteboard. Give me a second. Oops, nope, not this one. So let's put it here. Okay, now that I have this, so what you can see is that there is this magnetic north pole and magnetic south pole over here, and it kind of like contradict with the worksheet's idea of a magnetic pole. So if you read the text over here, you can see that they are saying that there is an imaginary magnet inside the earth. So this is the part where you can read. So this magnet is not a compass. This magnet is actually the imaginary magnet for the earth. So actually, if you are being asked in O level to draw the magnetic field for the earth, please remember that on the northern hemisphere, it is where the south pole of the magnetic south pole of the earth is. So that's why you can see that down here the magnetic field line is going into the earth. Okay, so why is it that it is called magnetic north here? So I'm suspecting this magnetic north is referring to the compass magnet. So let's say let me erase all this distracting thing. So let's say I put a magnet on here, like a giant compass. This compass would have a magnet, right? So imagine now there's a magnet over here. Yeah. So this magnet will have 2 poles. So since the imaginary magnet of the Earth is south on the northern hemisphere, then what kind of pole would point towards it? As in the compass magnet's pole, it will be the north. It will be the north pole of the compass magnet that will point towards the magnetic south of the Earth. So I guess that is the reason why this is called the magnetic north. This magnetic north is referring to the north pole of the compass magnet that is pointing towards it. Okay, so actually there's no discrepancy between the worksheet and the textbook. It's just that this magnetic north, when it is in the textbook, this magnetic north pole is referring to the compass magnet. So this magnetic north is referring to, oh, if I put a compass here, the compass will point according to the magnetic field, and it will point towards this part, which is where the magnetic south pole of the Earth. So anyway, the main thing that you need to absorb is that in the northern hemisphere, it is actually where the south pole, the magnetic south pole of the Earth, and that is where the north pole of the compass will point to. Okay, so let's write this here. If you need to know what is the key thing you need to know, if you are being asked to draw the magnetic field of the Earth, then make sure you are drawing the field line going in and getting out. Yeah, it will be slightly slanted, so it will be like that. And then after that it will be like this. Okay, if you are being asked to draw the magnetic field of the Earth, then this should be the way. So just remember, in the northern hemisphere, it is the magnetic south of the Earth magnetic field. Can? And that is also why the compass magnet, the north pole of the compass magnet will point towards. So down here, the north pole of the compass will point to the magnetic south of the magnet. So down here, you can put down magnetic south. Okay, so I hope you understand now. Most of you did very well for question 2 and 3, so I'm not going to touch on that. Question 4, similarly, you all did pretty well. Question 5, some of you missed the requirement. You need to tell me the poles, the resulting poles. And whenever you want to make permanent magnet, make sure you use a hard magnetic material because you do not want to lose the magnetism. Down here, question 6 is you all did pretty well. The key thing that some of you miss is domain. Domain doesn't have magnetism, it has alignments. Yeah. Then down here, I think some of you do not understand what's the meaning of induced pole. So induced pole is like your induced charge. Induced means that it is temporary and it is being influenced. So similar to an induced charge, once the charge body is removed, then everything goes back to normal. So similarly, now that instead of you have a charge object, you have a permanent magnet like here, then this permanent north will induce south over here. Okay, so these are what it is called the induced pole, and for magnetism, the poles will always come in pairs. Down here, nothing much. This one, just be careful. I'm looking at what does it indicate, and for forces, there's no such thing as the line of a force. There's only direction or magnitude. Okay, then as for here, some of you go and put south, which is wrong because if it is imaginary south pole, then it will get attracted by the north pole rather than repel. So that's why the magnetic field line actually represent imaginary north poles. Down here, I have a typo. Please add that in to be grammatically correct. Okay, down here, this part for your part C, most of you didn't get it. So if you read the text, the compass pointer will always point at a direction tangential to the line. So if now I zoom into this, then the field line will be like this, right? This is my field line, and I am putting my compass right here. So this is my center of the compass. So therefore my pointer will point this way. Okay, so that's how you get it. Yeah. Okay, whenever you are drawing your magnetic field pattern, some of you have a very wrong idea. So let's not focus on 5 or 6 or 7. Whenever you are drawing, firstly the line will come out evenly from your magnet. So because of that, then this spacing, the one in pink, this spacing should be even. Okay, so the dot here will tell me where the line come out, and I want the line to come out from evenly spaced position. Okay, so the first thing is like drawing your electric field. First, you draw the line of symmetry, so it will be an up-down line of symmetry. Okay, and usually there will only be one straight line. So for me, I think I can't draw it freehand, so let me get my ruler and draw it. So yep, so I have this. Then after that, I will branch out from this dot and I will branch it out this way. So I'm drawing freehand, so you can do it with practice. Okay, so freehand. Right. No need to focus so much on the loop. Yeah, you can do the loop if there's space, but if there's no space, then forget it. the key thing is that there must be symmetry and the line shouldn't cross. There will be one straight lines. So there are 3 key points. Number 1, okay, the starting point of your fill line. So the starting point of the fill line refer to the pink color highlighted part, should be evenly spaced. Then number 2, there should be, most of the time, should be one straight line. And this one straight line usually is the line of symmetry. Usually. Okay, and of course number 3, must ensure that there is no crossing of lines. So it is very similar to your electric field. Then lastly, you just need to add in the arrows. It will get out of the North Pole and into the South Pole. So that's this. Okay, this one is the same thing. There should be the line of symmetry. Oops. Then after that, make sure, oh, I didn't draw it in the center, so maybe I follow the same method. I dot out the starting point first. 2, 3, evenly spaced. So usually I will just get 3 pairs and that's it. Oops, wrong again. Hey, what happened? Yeah, this is the problem of drawing on an iPad. So some of you may be asking me, why not draw 3 straight lines? That's because, remember at the very beginning, the lines, right, all these lines are actually your imaginary North Pole. Correct or not? So it means that the line will repel against each other. And if the line repel against each other, then you cannot have 3 parallel lines here because they are repelling, they are pushing each other outwards. So that's why there's only one straight line, that's the center, because if you're at the center, then the top one push you down, the bottom one push you up, so it neutralizes. So therefore you will have something like that, and the last line will bulge out even more. So once you are done, you can then draw the arrows and you are done. Okay, when you have repulsion, then just be careful, there will be asymptote. So I will first draw the asymptote. Yeah, when you draw your asymptote, then after that, mark out your evenly spaced starting point. So I mark it out. Then after that, you want to draw the line, right? Most of you tend to draw your line like this. This is wrong because down here you have made a 90-degree turn. So that's why I refer you to this statement here. There should not be a 90-degree turn, so this one is wrong. So if you see this is wrong. How should you draw it? You should draw it this way. So it should tend towards the asymptote but not touching it, like that. Okay, so this one not very good also. I don't like it. So draw until I'm happy when I am doing my homework. So during the test, I can draw it very quickly. So most of our class can draw, judging from the paper. Lucky. Okay, so I will erase this dot. What? Okay, so this one maybe I move it further, move it a bit further, move it a bit further, move it a bit further. Then lastly, put in the arrow. Some of you asking ask me over WhatsApp, how about this area here? Yeah, this area here is actually a region whereby there will be no magnetic effect because the line will just repel against each other and cancel each other's effect. Okay, for 10A, it is actually any magnetic material, but most of the time they use iron, which is a soft magnetic material. So what happened here is that for question 10, we are focusing on magnetic shielding. So actually they will redirect the lines through the object. So some of you draw things like that. This is wrong because the line will not take a curve. Some of you were doing this. This won't happen as well because the whole idea of magnetic shielding is that they want to compress all this line that comes out into the iron bar. So actually it looks like this. So make sure that it is still evenly spaced. So I didn't do a good job, so I do it better now. Okay, and the last one will be like that. So all the lines are actually confined by the iron bar, which is now doing the magnetic shielding. So actually in this arrangement, it is also good for the magnet. So when you do this, this is actually a way to store permanent magnet. They will put in a pair like this, so that the domains near the end of the magnet, so I'm referring to these domains here. So the domain near the end will not get distorted by the Earth magnetic field, but rather they will all be pointing towards this region. Yeah. So if you zoom in to this, or did I erase? If I zoom in to this part, so if now I draw the North Pole, so I'm zooming in from here to here. Okay, how will the magnetic domain looks like? It will be like that, like that, like that. Normally they will, because each of these arrowhead represent a North Pole, so this North Pole here will repel against this North Pole. So usually permanent magnet near the end will be weaker because the domains are repelling against itself. So what happens is that you can strengthen that by putting a iron bar. So let's say I put a iron bar here. So when I put an iron bar here, the magnetic field line, let's use red, the magnetic field line will actually go like that. So because of that, then the domain pointer over here will be very, very straight. It will be like this. So in a way, it can help you store, prolong the life of the magnet, okay, because it reduce the effect of the Earth magnetic field on this permanent magnet. Okay, last but not least, I have this. What you need to be aware of is that some of you draw too many lines, some of you draw not enough line. So what I do is that I will draw 1, 2, 1, 2, 3. So I will dot out and make sure that it is evenly spaced. Then some of you like to draw like that, go straight. And then after that you try to squeeze into the ring. It won't happen because, like I said before, the magnetic field line is made up of imaginary North Pole. So they will repel against each other. For example, this line and this line, the green one, will repel against each other. So what will happen? This line in yellow will bulge out because there's space on top. So because of that, to draw the line properly, you have to draw it like that. So this one will slowly bulge out, and then bulge out. But now with the ring, right, you will try to attract it inside. So the same thing, you feel that. Okay, in another way, you can imagine it this way. If I have this, right, then there will be an induced south and an induced north here. Agree or not? So because of that, your line will go like that, like this, and like that. It's very similar to the electric field. So you see here there's a slight bulging, this part and this part, because they are repelling against each other. Yeah. So I will draw the outside first before I draw the inside. So now I draw the outside already, right? Then now I draw the inside. So the inside will go in, the domain will align, and then after that it will go like that, then it goes like that, then it goes like that. Okay, I don't know how I'm going to end it, but let's try. And then like that. Then down here is the same thing. It will be like this. It will be like this. It it will be like this. Oops, actually I don't really like it. This one no good because sharp turn. Yeah, so you have to do it with patience and with patience and elegance. Yeah, and make sure it is symmetrical. So it looks somehow symmetrical and it is good enough. And then lastly, add the arrow. Yep, and then of course the part where there's no magnetism will be here, which most of you got it correct. Okay, the part 3 mainly is to highlight to you that wood does nothing to the magnetic field. So just treat the wood as if it is not there, then it will be very easy. So first there will be the line of symmetry. So, then after that, make sure that spacing is even. So I will dot out the starting position. Then remember there will be slight bulging because the line will repel against each other. So I will have like that. Just slight bulging will do. Okay, then of course finally just add in the arrow. Yeah, so that will be all for your magnetism, and now you should be on the way doing 21.0. Okay, so easy, right? Ayo, very ugly. I want to be very 帅 one. Okay, but I failed. Never mind, practice make perfect. See you.